Okay, so we're going to continue looking at these trig ratios and the CAST rule. And remember, the CAST rule tells us which ratios are positive in which quadrants. Starting in the bottom right and working our way around counterclockwise. And again, the reason we do that is because when trigonometry was first developed, we're talking about the sun moving across the sky. It starts in the east and sets in the west. So that's why it goes counterclockwise. It says which quadrants are indicated by the domain restrictions. The first one is between 0 and 90 degrees. So not only can we name the quadrants using our CAST rule, but we can also name them numerically. Again, starting in that first quadrant and working our way counterclockwise. That's how the quadrants are numbered. So the quadrant between 0 and 90 degrees is quadrant 1. What about if it's between pi on 2, which is at the top, and 3 pi on 2 at the very bottom? That will be quadrants 2 and 3. From negative pi to positive pi, if you start at negative pi and you get to negative pi by starting at 0 and going pi in a clockwise direction. So negative pi would be there, and if you're going to go to positive pi, starting at 0 and going pi in a positive direction, counterclockwise, takes you back to that left arm. And so you're going to go through all three quadrants from negative pi to positive pi, all four I should say. If we list them in order from start or first quadrant to last quadrant, we would start at quadrant 3, we would move to quadrant 4, then quadrant 1, then quadrant 2. Going from negative pi to positive pi, we go through all four quadrants in that order. Then if we went from negative 360 to positive 180, well, negative 360 is coterminal with 0. To positive 180. So if you start at negative 360, so you're starting here at 0, and you're going to go to positive 180, you're going to move in a counterclockwise direction. You would go through quadrants 1, then 2, then 3, then 4, but that just gets you back to 0. If you start at negative 360 and you go in a counterclockwise direction through the first four quadrants, that only puts you back at 0. So then you'd have to go through quadrants 1 and 2 a second time to get to positive 180. So you're going to go through all four quadrants, but you're going to go through the first two twice, starting at negative 360 and going to positive 180. Okay, this first example says the point A with those coordinates lies at the intersection of the unit circle and the terminal arm of an angle in standard position. So because both of those components are negative, that puts us in the third quadrant, somewhere in that third quadrant. To get to that place, if this is the point, that is the point negative 3/5, comma, negative 4/5. And there's a couple different ways we can look at this, okay? We can remember that we're dealing with the unit circle, and remember that all the coordinates on the unit circle tell us either the cosine or the sine, the two coordinates. The x value tells you the cosine. This tells us that the cosine is negative 3 over 5. So if we draw a reference triangle by drawing a line straight to the x-axis, and the reference angle is always the angle between the terminal arm and the x-axis, The cosine, which is adjacent over hypotenuse, is negative 3 over 5. So the adjacent side will be negative 3. And it's negative 3 because not only are the coordinates of that first point negative, but also from the origin you're going to the left, that's what makes this side negative. The hypotenuse is always positive. And the second point is negative 4 over 5, which is the sine ratio, and the sine is opposite over hypotenuse. So the opposite side will be negative 4 over 5. So that's one way to look at this. The other way to look at this and say, you could say, well, if point A has coordinates negative 3/5 first, that means you're going to go negative 3/5 units to the left. And you're going to go 4/5 units down. So instead of this sign being labeled negative 3, it would be labeled negative 3/5. Instead of this side being labeled negative 4, it would be labeled negative 4/5. And then the hypotenuse then would be 1 because it is a unit circle. But those three sides labeled as negative 3/5, negative 4/5, and 1 would be in the same ratio as the way I have them labeled here. These three sides, the way I have them labeled, are all 5 times what they would be if I labeled this negative 3/5, this negative 4/5, and this 1. So the ratios will have the same value. The ratios of opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent will have the same value when you work them out, no matter how you label the triangle. It's just easier to label it like this because you don't have any fractions to deal with. So we've drawn a diagram to model the situation. We're asked to determine the values of these 6 trigonometric ratios for theta. And they are the sine, the cosine, and the tangent of theta. And then we'll have our 3 reciprocal ratio. The sine is negative 4 over 5. Our triangle tells us that because it's opposite over hypotenuse, but also the coordinate tells us that. The sine is the y value. The cosine is adjacent over hypotenuse, negative 3 over 5. The triangle tells us that. The coordinate also tells us that. The tangent is opposite over adjacent. It'll be negative 4 over negative 3, and a negative divided by a negative is a positive. So you could get it that way from the triangle. You could also get it from the 2 points by remembering that tan theta is sine theta divided by cos theta. The sine is negative 4/5 divided by the cosine, which is negative 3/5. We divide fractions by multiplying by the reciprocal. The 5's cancel, and you'll have negative 4 over negative 3 or positive 4/3. So either way, you'll get the same value for the tangent. So there are our 3 primary ratios, and then we have our 3 reciprocal ratios. Cosecant is the reciprocal of sine. Secant is the reciprocal of tan. And secant is reciprocal of cosine. Cotan is the reciprocal of tan. And it doesn't matter whether you let the 5 be negative or the 4 be negative for cosecant. It's a negative fraction. The value of it is negative. So there are our 6 ratios. Example 2, the point A with coordinates negative 3, 4 lies in the terminal arm of an angle theta in standard position. What is the value of each trig ratio for theta? So this really isn't much different, but we're in a different quadrant because although x is negative here, y is positive. So to get to that point on the terminal arm, which is up there, you have to go 3 to the left and 4 up. So that gives us the lengths of those sides. The reference angle, theta, is always between the terminal arm and the x-axis. In this case, we're not told that it's a unit circle. We're not given any information about the hypotenuse, so we need to determine it using Pythagorean theorem. So it doesn't matter which side is A and which side is B. One of them is -3, the other is +4. When you square and add the 9 and 16 together, you'll get 25, and the root of 25 is 5. So there's the length of the hypotenuse. And now we can state the sine, cosine, and tangent of theta, and then we can do our 3 reciprocal ratios. The sine, which is opposite over hypotenuse, is 4/5. The cosine adjacent over hypotenuse, -3/5. The tangent opposite over adjacent, 4/-3. The reciprocal of sine is the cosecant. The reciprocal of cosine is the secant. And the reciprocal of tan is the cotan. So there's the 6 trig ratios. So for example 3, we're not given the point, we're given what the value of the sine of theta is. Sine of theta equals -3/4. And then we're also told that we're in the third quadrant, between pi and 3 pi on 2. You see, without that stipulation of being in that quadrant, we could actually be in quadrant 3 or 4, because those are the two quadrants where sine is negative. The CAST rule tells us that. The two quadrants where sine is positive would be the A quadrant and the S quadrant. So it's negative in the other two. However, we are told that theta is between pi and 3 pi on 2, which means that it's only in the third quadrant in this case. And so like we did before, we can draw our reference triangle by drawing a line straight to the x-axis. So again, that gives us a right triangle, and the reference angle theta is always between the terminal arm and the x-axis. And we're told that the sine is -3/4, and sine is opposite over hypotenuse. So the opposite is 3, the hypotenuse is 4, but one of them has to be negative. And we always remember that the hypotenuse is always positive. The opposite side is -3 because you're going 3 units directly down. Okay? So to find the exact value of the other 5 trig ratios, when we use those words exact value, it's going to be because we're going to get a radical for the length of the third side of the triangle. And we're going to leave it as a radical. That's exact. But that's where we need to start. Find the length of the adjacent side, the side that's along the negative x-axis. So if that's x, it'll be x squared plus the other leg is -3 all squared. Equals the radius 4 squared. So x squared plus 9 equals 16. When you subtract the 9 from both sides, x squared will equal 7, and then x will equal √7. But again, because it's going left from the origin, it has to be a negative √7. If you don't write that with a negative value, it will not satisfy the CAST rule when we write our other trig ratios. So again, we started with the fact that the sine of theta is -3/4. We were given that, but the cosine would be -√7 over 4. Again, leaving it as a √7 is an exact value, which is what we're asked to do. And the tangent would be negative 3 over negative root 7. So once again, a negative divided by a negative is a positive, but we also need to rationalize our denominator by multiplying top and bottom by root 7. So there are the two primary ratios that we're missing. The three reciprocal ratios, the cosecant is the reciprocal of the sine. The secant is the reciprocal of the cosine, which was 4 over negative root 7. So that'll be negative 4 root 7 over 7 when we rationalize the denominator. And the tan was negative 3 over negative root 7, so the cotan will be root 7 over 3. Again, it's positive because the tangent is positive once you deal with the fact that you had a negative over a negative. Example 4 says, if secant of theta is 2 root 3 over 3, and theta is between negative 180 and positive 180, determine the exact values of the other 5 trig ratios. So if the secant theta equals 2 root 3 over 3, that would mean that the cosine of theta is the reciprocal 3 over 2 root 3. And if you rationalize that by multiplying top and bottom by root 3, you'll get 3 root 3 all over. On the bottom, the root 3 times the root 3 is 3, times the 2 is 6. And then you can divide top and bottom by 3. And get root 3 over 2. So we've already determined one of the other 5 trig ratios. We've got the secant and the cosine. So we just need the other 4. And so now we're going to set up our terminal arm. And in this case, there's actually going to be 2 of them, because we're not told what quadrant specifically we're in. We just said that theta is between negative 180, which is there, and positive 180. So if you start at negative 180 and go to positive 180, you're going to go through all 4 quadrants. And so there's going to be 2 quadrants where secant or cosine are positive. There are 2 quadrants where the secant and cosine are positive. And that'll be the A quadrant as well as the C quadrant. The secant is positive 2 root 3 over 3. The cosine is positive root 3 over 2. So we're going to have 2 different triangles that we'll be looking at. 2 right triangles. And in both cases, the cosine, which is adjacent over hypotenuse, is root 3 over 2. So we're going to have to find the length of the opposite side. The opposite side to theta. Theta is between the terminal arm and the x-axis. So that will be there and there. In quadrant 1, the opposite side will be positive. In quadrant 2, it'll be negative. You see, when we use Pythagorean theorem here, it'll be root 3 all squared plus y squared equals 2 squared. Root 3 all squared is 3 plus y squared equals 4. Y squared equals 1. So y will equal positive and negative 1. Positive 1 in the first quadrant, negative 1 in the second, because we're going downwards from the x-axis in the fourth quadrant. Again, this is the only way that the cast rule will be satisfied. So we've got the cosine and the secant. We can now state the sine of theta. In quadrant 1, it'll be positive 1 over 2. In quadrant 4, it'll be negative 1 over 2. So we can say that the sine of theta is both positive and negative 1/2, depending on which quadrant we're in. And then the cosecant of theta, the reciprocal of sine, would be positive and negative 2 over 1, or positive and negative 2. And then for the tan of theta, depending on which quadrant we're in, it can either be positive or negative 1 over root 3, or positive and negative root 3 over 3. Whereas the cotan is the reciprocal of plus and minus 1 over root 3. That would be plus and minus root 3 over 1, or plus and minus root 3. So in the fourth quadrant, cosine is positive, as well as the secant. However, tan and sine, as well as their reciprocals, are negative. So that's why we have those plus and minuses there. Okay? So what you can work on for practice, page 202, questions 3, 8, 9, and 12. That's what you can work on for practice. Yep. And I will post those solutions to Google Classroom so you can check your answers.